The history of concrete starts with materials from the earth. It is here that we find the base ingredients of one of the most revolutionary materials in the history of mankind: limestone, clay, sand, gravel, water. It was in an attempt to imitate nature that man created the first concrete, thus obtaining the very first pourable stone. One of the most significant concrete constructions is the cupola of the Pantheon in Rome. It is an incredible feat of engineering and has been standing for 20 centuries. In the 19th century, the invention of Portland cement revolutionized the technology of construction materials and transformed the concrete of the ancient Romans. Modern concrete was born. In this period, Europe saw its first buildings constructed with steel-reinforced concrete. Today, concrete is the most used construction material in the world. It is common to find megastructures like the bridge over the Rio Negro entirely built using this material. Let's discover the microstructure of our material. What makes it so strong? Concrete is a composite material where sand and gravel are bounded together by a cement paste, made of cement and water. Cement powder and water react and harden through a process known as hydration. During hydration, the cement grains enter into contact with water and they begin to form a strong rods network structure, which is responsible for the final strength of concrete. If there is not enough water, concrete cannot be mixed and poured. If there is too much water, the grains will be too far apart and concrete will be porous and weak. If the ratio between water and cement is correct, the cement grains create strong bonds, both between each other and with sand and gravel. Sand and gravel must be present in the correct proportions in order to guarantee the strength of the concrete. A proper mixing is what guarantees that all the components are distributed uniformly. There are various errors that may occur during the process and that may compromise the quality of the concrete. If not enough water is used, concrete cannot be mixed and poured. If too much water is used, coarse aggregates settle to the bottom, and concrete will not be homogeneous and thus weaker. Another error is that of mixing the concrete too long before using it. After about an hour, cement has already started to bind. Prolonged mixing breaks the bonds and compromises the final strength. These errors can reduce the load-bearing capacity of concrete. Mistakes in mix proportions and mixing